So number 15, y prime is equal to, well, let's rewrite y as 2 times the quantity 9 minus x squared raised to the 1/4 power. So therefore we can just use the chain rule here. If we had 2 times something to the 1/4, we would write 2 times 1/4 times that something to the 1/4 minus 1 times the derivative of that something, which is exactly what we are going to do here. So the something is the 9 minus x squared. So the chain rule says 1/4 times 2 times what's inside to the 1/4 minus 1, that's the power rule, and the derivative of the inside is just going to be negative 2x. Let's simplify this a little bit. 2 goes into 4 twice, so we have 1/2 times 9 minus x squared to the 1/4 minus 4/4 is negative 3/4, and then again the derivative of 9 minus x squared is negative 2x. So I'm looking at the answer, and that is the correct answer, but the answer in the back of the book shows it as having the 2's cancel and a negative x up on top, and then having the 4th root of 9 minus x squared to the 3rd power. That's just rewriting the expression here as in radical form, but putting the radical in the denominator. So that's it. In number 45, we're supposed to find the slope of this curve at that point, or the slope of the tangent line to this curve at that point. Well, I'm not really sure what the curve looks like, nor do I really care too much, because if I want to know a slope, I want to know the slope of any tangent line is equal to y prime, which is equal to, now the derivative of ln of anything is 1 over the anything, but if that anything is something other than x, then we have to multiply by the derivative of that anything. That's just the chain rule. And so we get 3x squared up on top, and we get x squared on the x cubed on the bottom, so that x squareds cancel, we get 3 over x. So that's y prime. That's the slope at any point. Well, at the point 1, 0, that's the slope at the point when x is equal to 1, which is equal to 3 over 1, which is 3. And that's it. Number 51, we're just finding y prime. Y prime is when we take the derivative of the sine, we're going to get cosine of whatever. But that thing, that whatever, is not just x. So we're going to multiply by the derivative of that thing, pi x squared. Well, the derivative of pi x squared is just, well, if you think about the derivative of, let's say, 3x squared, because maybe the pi is throwing you off. The derivative of 3x squared is 2 times 3, which is 6x. That's it. So the derivative of pi x squared is 2 pi x. And so if we multiply the 2 pi x times the cosine of pi x squared, we get 2 pi x times the cosine of pi x squared. Derivative of this quotient is I'll use the quotient rule. Sometimes I try to look at this as cotangent of x, which is cosine of x over sine of x, and then divided by the sine of x over 1. So sometimes when you have a fraction like this, you can simplify it, but in this case we're just going to get cosine of x over sine squared of x. So that's not really going to help us to simplify this at all, so let's not. Let's go ahead and just use the quotient rule. Low d high, so sine of x times the derivative of the cotangent. So d high, cotangent, negative cosecant squared, and then minus high, cotangent of x, times the derivative of the denominator, d low. So derivative of sine of x is cosine of x all over sine squared of x. And here we have sine of x, so we have negative sine of x times cosecant squared, which is 1 over sine squared of x, minus cotangent squared, which is cosine over sine. There's a few different ways you could go about doing this. So let's make that cosine. Let's put everything in terms of sine and cosine. That might make it easier here. And then over sine squared. So we could see we're going to be able to cancel one of these signs right there, and we can't cancel anything there, but we do have a common denominator. We have -1 minus cosine squared over sine x. So let's multiply top and bottom by sine. I don't know if this is going to help us at all. And so those signs are going to cancel. So we get, with that sign, so we're going to get -1 minus cosine squared of x all over sine cubed of x. So if we factor out a -1 from the numerator, we get 1 plus cosine squared of x all over sine cubed of x. When I look at this, I think it must have made a mistake with the minus signs, plus signs, but yeah, I'm not seeing where we can 1 minus sine squared. I mean, we can maybe substitute 1 minus sine squared for this, 1 minus sine squared, and we get 1, -1. It's getting busy here. Let me move it up here. So we have -1 times 1 plus 1 minus the sine squared of x. This is just a numerator now. We get -1 times 2 minus the sine squared of x. We get -2 plus the sine squared of x. This is not really going anywhere. So, I don't know. I would tend to just leave it alone, like right there. Maybe that's it. Yeah, I just checked in the back of the book, and that is in fact the answer in the back. In fact, this is what it shows as the answer in the back of the book. So I tried to simplify it. I thought, well, maybe something is going to cancel, but nothing canceled. So there you go.